So they've gone off and they've started doing other things. But we have these strands of DNA that aren't quite connected yet. And so what happens is DNA ligase will come in here and he brings those together. Right there, he'll do it right there. And now, where we once had, sorry, I was like, where did the lids go? Now where we had these DNA sections that weren't connected, those kind of fragments, now we have just added on to this leading strand, we've just made it essentially longer. And it'll continue doing this, and then DNA polymerase, go ahead back for him. He'll come in, DNA polymerase 1 will come in, and he's been going, he's heading this direction, so he's left behind this strand right here, and he keeps going, and he'll go till it gets right here. And then you'll have DNA polymerase 1 will come and erase that.
What brings in, because the polymerase 3, we had to have something bring it there, didn't we? Or no?
Why does it go there?
Is it just
your
now
question?
Yeah.
Yeah, it only has one function, one
so
job.
It doesn't need something to bring it there. It just goes.
I think getting deeper than what I would.
Okay.
There's something that brings it there. No, I don't know. Yeah.
So we're talking about how DNA polymerase 3. You said that it was producing RNA nucleotides. Is that what you said? Okay. So it's RNA primers that are placed on there.
By primase.
By RNA primase.
Yeah.
And so why is it an RNA primer when they're adding DNA nucleotides?
Good question. Why don't they just use a DNA primer?
Exactly. Yeah.
I don't know.
Okay.
I could think about some reasons. RNA doesn't quite, maybe it's easier to take the RNA off of there. Maybe it's easier to have an RNA as a primer because that can more easily be recognized by DNA polymerase 1.
Mm-hmm.
Because somehow that primer has to be different so that the DNA polymerase 3 knows where to come in and start.
Okay.
And so that could be a reason why, if it is different, RNA would be a good option because that's easily recognized as different.
Mm-hmm.
So that you can come on and add on the extra fragments. And also, it would be easy for, if there's a lot, it's already there, it's something we made. It's easy for that DNA polymerase 1 to kind of switch out, I would say.
So the fragments that are left, in between, you're saying how there's fragments left, those are the Ozaki fragments, right? And they're still by the ligase, put together, kind of.
Yeah, all those little fragments we brought back, they'll be, once the DNA's there, they'll be glued together by the ligase, right?
Oh, okay. Great.
I just have one question. It's kind of silly, but I just want to make sure that I'm clear because on the top picture, you drew the DNA strand going this way.
Mm-hmm.
And then on the bottom picture, I thought that you were drawing the DNA strand going that same way, but then your Okazaki fragments were going this way. So do the leading strand and the lagging strand go opposite ways, or are they going the same way? Did that make sense?
Yeah, that does. So your lagging strand, what I think that, when I think of the lagging strand, is these parts behind that aren't quite here. If you just go by what's on top and what's on bottom, you could just flip it this way, and then it's still, it's flipped. So as far as paying attention to how I did this, I guess I could have been a little more careful. I didn't even label 5' and 3', but this the lagging strand will always be behind, this leading strand. It doesn't flip from this side to that side, okay?
Okay. The way that you drew it, for some reason I was like, wait a second, are these going towards each other?
No.
I was a little confused for a second, but so the DNA is getting, in
it's
your picture, the DNA is getting copied this way, and then behind it are your Okazaki.
Right, so this is continuing going this way, and then the helicases open more up, and now you have these opening, and they're still going this way. You still have to go, you can only go 5 to 3. You can never go 3 to 5, so that's why,
Wait, 5 to 3, I thought it was
5 to 3, but according to the other strand, it'll be 3 to 5, if that makes sense, okay?
Because they're anti-parallel.
Right.
Well, the top strand would be 5 to 3. The bottom strand would be 3 to 5.
This strand would be 3 to 5, but you're not coding with that strand. You're coding with this strand, so you have to go to the 3 end on this side.
You can only go one direction. It's like a highway. So you can't the lagging and leading don't.
I just know that when we those little the homeworks when we would, there was like a code of DNA, like there were 2 lines, and then we had to figure out which one it was. We had to read it 3 to 5.
Right. So
it sounds like you're saying read it 5 to 3.
Well, you kind of are. It's your point of reference. If you look at this strand and we'll say it's going like this, dang it, all the markers aren't matched with their leads. So. Okay, if we were saying this top one is 5 to 3 right here, okay? When we made this,
did it start over on that 3 end and then?
Well, when this fragment was made, they added on each little nucleotide going this way. But with this one, you remember how they run anti-parallel, opposite, right? Well, then that means this one, it's now 5' is on this side, and it's 3' on this side. So it has to go this way. So, according to the new strand, we are going 5 to 3, but it's anti-parallel to the original strand, which we're using as our copy, and it will be going opposite of that, which it should, because we know they run anti-parallel.
Okay.
So that can get confusing, but once you grasp it, then you got it. Yeah.
So the leading strand, it's going to copy 5. Well, it's obviously they're all going to have a 5 to 3 strand, right? But the leading strand, it'll be from 3 to 5, like the strand that you're looking at. I don't know.
Your leading strand and your Okazaki fragments, they all code 5 to 3.
Right.
The same way, yeah.
Okay.
Does that answer your question?
Yeah.
I was trying to understand it.
Yeah, that
Okay.
does.
Okay, yeah. They can only go this way, which makes sense why we need the primer. Because you can't just tap onto the end of this thing and go backwards. You can't do that. So that's why it seems tedious, but you have to come in and you have to put a primer down here, and you have to continually do these little sections. You'd think it'd be easy, let's just jump on the back of it and go the other way and just do a straight strand. And avoid having to glue them all together, putting down the primer, taking out the primer. But since you have to go 5 to 3, according to the strand that's being made, that's why we have to have all these little fragments. So they keep going on. And you keep adding more, after these will come together, but you keep adding more fragments as this opens up more and more and more. But you can't add, you can only add as many fragments as you have opened up.
Right.
So as more opens up, you can put more primers down.
Okay.
So, do you feel better about that? I feel like you have a question. You're like digesting the point.
No, I just, for a second, I was like, what's opening it up on the other side? But then I realized on the bottom, there's helices going down that side. And then I realized how the Okazaki fragments are being made. And then I just had like this moment of revelation.
There's a moment
just
of
like,
awe.
oh my gosh, this all makes sense.
Okay, so just to double check, it's always read 5 to 3, but it's replicated. Synthesized, yes.
Well, you say duplicate or replicate.
So this one's
Synthesize.
being read 5 to 3, and the new one is being like replicated 5 to, wait a second, no, I'm getting it wrong. 3 to 5 and then 5 to 3.
Yeah, so this new one, it's 5 sides on this side, so you can only add sections on this way.
Yeah,
So
it's
that's
going to 5 to
synthesizing. Or replicating.
Yeah.
Because
So
you only
read
read
3 to
there.
5.
Yeah.
If you were saying compared to the other strand, it is, backwards. But we're not synthesizing the strand or replicating.
So you're kind of okay, gotcha.
So you read it 3 to
Yeah.
5.
You always
And
add
you
on 3'
Read it
end.
3 to 5.
Right.
To like
See, that's what
three
it,
prime
that was
end.
You
that's
read
what
it
was
3 to
messing
5,
up was
but you
because
replicate it 5.
So
Brother
this-
Julio kept on saying
this
read
one-
it 3 to 5.
You do. You
But
read
then-
it 3 to
Let
5.
me
I'll
ask.
take them up.
Here's a cool trick question. If this strand right here will say 5 to 3 is, I gotta have the right marker lid on it, doesn't fit. Right? If this strand is 5 to 3 this way, which way is 5 to 3 on this strand?
Yeah.
3 to 5.
Tell me what number.
3.
And
5.
you don't want me to write down 10? Just kidding. I thought 10. Perfect, that means we get it. So it makes sense that this strand has to be 5 to 3 because that's the anti-parallel, just like the other one was.
Yeah.
And so then this new strand that's going to be copied, what's it going to be?
5 to 3 straight.
5 to 3. Because it has to, its new partner has to be opposite, Opposites attract,
Gotcha.